So, good evening, everybody. Thank you so much for joining us for today's London Java Community event. Let me introduce myself. First of all, my name is Abby. I work with Barry Cranford, who is the founder of the LJC, and I have the privilege of hosting this event. For those of you who don't know, the LJC is just one of the, I believe it's now 15 communities that is run by RecWorks. RecWorks are a tech recruitment company with a huge difference. As a company, we believe that recruitment really can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. If people want to learn and others want to teach or share their knowledge, we are happy to connect you through our communities and events. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, we have run hundreds of events for engineers, developers, students, graduates, and CTOs. We have run lightning talks, conferences, hackathons, all sorts. Earlier this year, we made our 4,000th introduction through our Meet a Mentor program, and we're really excited to hit 5,000 introductions through that community as well. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you would like to know more about any of our other communities, please do get in touch with myself, Barry, or Helen Lewis if you know her, and we can take it from there. Just to let you know, the recording of today's session will be available on YouTube in a few days' time. I can put the link to the channel in the chat for you, but equally feel free to message me directly on LinkedIn and I'll be able to send you the video when it's ready. That's absolutely fine. Just before I hand over to Joe, there will be a chance for Q&A at the end. So please do, if you think of any questions as we're going through, make a note and then I will be able to open it up to you guys when Joe has finished. But with no more ado, over to Joe for his amazing talk this evening, and we're really excited to hear from you.
Thank you very much, Abby, and good evening, everyone. So, as Abby mentioned, my name is Joe, and I'm a senior software development engineer at GoCardless. GoCardless, if you haven't heard of us, we are a bank payment network. We facilitate merchants being able to get paid by their customers directly from their bank accounts using a mix of direct debit and open banking technologies. On a typical business day, we'll see tens of millions of pounds flow through the GoCardless network. And where I work in the global network division, our responsibility is to make sure that that money we collect goes where it needs to be when it needs to get there. Which may lead some of you to wonder, why on earth would we even think about testing in production? Given the amount of money that we're handling that isn't ours, given the fact that we are a regulated financial institution, why would we do such a thing? Well, the answer to that is because the definition of the phrase testing in production has undergone a bit of a shift in the industry over the past few years. Back when I started my career in the early 2010s, the phrase testing in production, it was generally a synonym for not testing anywhere else. And before GoCardless and a previous part of my career, I was running a level 1 and 2 support team. And I saw a lot of this style of testing in production, and this style makes nobody happy. So definitely don't do it. But over the course of the past decade, software systems have become increasingly complex. Big monolithic systems have been broken up into more microservice architectures. As much as I hate the buzzword, it's still a thing. And the complexity of a modern software system has gotten too big to fit into any one person's head, or for that matter, into the heads of an entire team of people. And this has exposed a bit of a shortcoming in pre-production testing, in that you can only test the known unknowns. You can only test the scenarios that you can think about in advance of putting your systems in production. There will often be a set of unknown unknowns that are much harder to test in a pre-production environment. You can't test them using automated tests because, well, if you could, then they're by definition known unknowns. And staging environments, you might get lucky and someone upstream of you is testing something that that causes a surprise in your staging environment, but oftentimes it's more a representation, again, of the scenarios you'd thought of. And, you know, if you're not careful, this can turn into confirmation bias. So given that, the only real place where you can really test these unknown unknowns is in a production-like environment. And what I want to talk to you about today is a situation at GoCardless we had recently, where we did a minor re-architecting of part of our systems, decided to run a test in production, and running that actually prevented a production incident in our systems. So just to put a little bit of context behind what it is that that we did. So one of the things that we need to have in order to be an effective payment network is we need to understand, with the money we collect, where it is at any one time, how it got there, and why it got there. So we had developed a journaling system based on standard double entry bookkeeping practices. And without turning this into an accounting 101 course, basically with what that means is whenever you get an event in the real world, you will basically pick two books, two sub-accounts, if you like. One of those books you will credit, the other book you will debit, and everything across the system should balance out to zero. So with that, our journaling system, we receive events from a number of different places. So we receive them from the payment schemes that we integrate with. We receive them from our merchants who interact with our dashboards, our APIs, and our partner integrations. And we receive them from our own internal tooling that covers things like deducted fees and payouts and so on. So what we want to do is we want to normalize these into a common format, pass them into our booking process, and that booking process will then select the books that need to be credited and debited, update those books, and send new balances to our downstream systems. Now, this has worked really well for us up until now because the network that we built has been relatively simple. The way funds move around has had a lot of commonality and very little complexity. But as a result of a combination of factors, both regulatory needs as well as needs coming from prospective merchants and prospective partners that we want to work with, we've come to realize that the network that we're going to need to build is going to need to be a lot more complex than what we have today. So one of the ways that we decided to manage that complexity is to move this book selection process upstream one level. So these normalized events will now contain exactly which books need to be credited and debited, with this booking process basically doing what it's told. But we really needed to make sure that the balances that we publish on the other side do not change in any way, neither in structure nor in content. Now, when we got to code completion, we were about 99% sure that everything would work fine. But in our team, we have what I like to call a fear of the unknown unknowns. And so we figured that there was about a 1% likelihood that there would be some edge case that we'd missed somewhere, and that could cause us significant problems if it were to be uncovered in live production. And it also just so happened that we were code complete in the days leading up to when I was due to go on holiday anyway. So we decided that we were going to run this in production in validation mode for 2 weeks and run it alongside the existing code. And we figured that over the course of those 2 weeks, one of two things would happen. Either the edge case that we had feared would materialize, in which case, great, we can go in and we can fix it and we can revalidate before putting it live, or that edge case won't materialize, in which case, great. Our level of confidence now goes up from 2 nines to 4 nines, and that's gives us the confidence that we need in order to put such a change into production. So that's the why we wanted to run this test in production. But you also need to think about how to do such a test in production. And when you're designing such a test, you need to bear two very important things in mind, which may sound obvious, but they're worth emphasizing. The first is that it is production. And it's an environment where if you get things wrong, there are significant consequences. In our case, if we get this wrong, it could mean millions of pounds going to the wrong place, and that would be a disaster. In your systems, these consequences will be equally unpleasant. So care really needs to be taken when you're doing any kind of testing in production. And the second thing to bear in mind is the entire reason we're testing in production is because we don't have enough confidence to just put it live. If we did have that confidence, we'd skip this phase entirely and go straight to putting it live. So you need to plan for the possibility that the refactoring that you've done is not quite right, and that there will be issues and you need to be able to deal with them, or your system needs to be able to deal with them in a seamless way as possible. So how do we do that? So the first step in your testing and production plan should be to test before production. Now, you may be thinking, well, hang on, didn't you just say a few minutes ago that testing before production has limitations? And it absolutely does. But just because something has limitations doesn't mean it's entirely useless. And in fact, you still need your strong suite of unit tests, functional tests, contract tests, and so on, as well as any additional tests you think you may need to run in your staging environment. And that's what gets you your first 2 nines of confidence. That's what gets you to 99%. And in our case, we actually had a number of points along the way where even in validation mode, our contract tests and our functional tests caught issues that would have caused us problems even in validation mode. So it's important you take advantage of these automated tests that you have built up over the lifetime of your system in order to get you to a level of confidence where running tests in production is actually a good idea. So once you've decided it's safe to test in production, how do you actually go about doing it? So the first thing you need to do, there will be a point in your system where the refactored code meets your existing logic, and the output of your refactored code is then used in existing code. And in our case, this was the point where we had selected the books that need to be modified. In your case, there will be some other point, but it's important to find where that point is, where the refactored code ends and the new code begins. And at that point, you want to add a checkpoint into your code. At that checkpoint, you want to run both the existing code and the new code. You want to compare the outputs and see if they match. Now, if they match, then great. We know that for at least that one specific input, we know that it has produced the same result, and it is safe to use in downstream systems. But remember, we still have this 1% margin of uncertainty that we need to do something about. And that 1% possibility that at some point you'll find an event where you won't have a match. So what do we do with that? Well, for that, we need to go back to first principles. What is the goal of a refactoring? The goal of a refactoring ultimately is to produce exactly the same result in a better way. So going back to the first part of that definition of getting the same result, it only makes sense that if you find there is a mismatch, or if your code finds there's a mismatch between what the old code has produced and what the new code has produced, in order for there to be no change in output, that means you have to use by default what the old code produced. And then the result of the new code, you need to chuck basically as hard as you can out of your system and make sure that it ends up somewhere that your development team can then later find and investigate the reasons for these mismatches. And it's important to track every single mismatch that occurs in this test, because every single mismatch will be the result of a bug in your refactoring. But what if you run this for 2 weeks and no mismatches get reported? Does that mean your refactoring worked? Well, it might do. It might also mean that your test didn't get hooked up properly. Or it could mean that there's a flaw in your matching logic and it's just matching everything blindly. Neither of these things would be very useful. So it's not just important to track your mismatches. It's also important to track your matches as well. Now, for matches, you probably don't need a full record of every single one. So in our case, we found that just having a count of the number of matches, as well as a sampling of about 1% of our matches, was sufficient. And that gave us two things. The first thing it gave us was a basic sanity check. We knew that our test was running. We knew that our matching logic was sound. There were no glaringly obvious issues with it. And it also gave us the ability to look at the breadth of the kinds of scenarios that were going through our system, and making sure that all of the various scenarios that we could think of coming up were at various points coming up over the lifetime of this test. So those were the general principles of how to test in production. As far as actually doing it, okay, we're back on. Excellent. So as far as the actual mechanics of how to run this test, so we use a Ruby gem called Scientist because we're primarily a Ruby shop at GoCardless. When adapting this talk for the LJC, I did some research to see if there is something similar in Java, and found that there's actually a port of the Scientist gem in Java called Scientist for J. And it handles a lot of the things that I had mentioned up to this point. So how Scientist for J works is you start by setting up what it refers to as an experiment, and you have the ability to plug in whatever tool you're using for metrics, whether it be Prometheus or InfluxDB or whatever else you're using behind the scenes. Specify how you want to publish your results. As I mentioned, we want to log every single failure as well as 1% or thereabouts of our successes. And then in addition to that, any additional context that we think we'll need to help us debug in the event that there's a mismatch, and or to help us to observe the various scenarios that are being run through. So in our case, this will include, among other things, the message that is being processed at that particular time. And then for actually running the experiment, we will want to pass in a functional reference to the existing logic that's going to be our control, the new logic that's going to be our candidate. Scientist will run both. It'll compare the output for both. It'll look at timings for both if that's what you're interested in. The run method will always return the output, of the candidate, or of the control logic rather. So, and that's what'll get used downstream, with the comparison all happening behind the scenes within the Scientist for J library. So that's how we configured our tests. So we came up to code complete. We had all of this set up ready to go. And it was Wednesday mid-afternoon, I think it was, when we put this test into production. Just so happened to be 2 days before I was due to fly away for a well-deserved break. And we weren't keeping a religious eye on the metrics. We were just checking in on them every now and again. One last check at the end of the day before we head off to the pub. We saw that matches were going up at around the rate we'd expect them to. Mismatches were staying at 0, so we were happy with how things were looking so far. We log in the next morning, check the metrics, and we see, oh, there have been some mismatches reported in this test overnight. So first reaction to that was, great. This testing in production has proved its worth. It has uncovered a bug in our refactoring. Good thing we didn't put this live yet. The second reaction was, okay, what actually went wrong here? So that's when we needed to start digging. So looking at our time series database where we're storing our metrics, we can see we had a very tiny uptick of mismatches at around 6 in the morning, at a rate of about 2 per million we'd seen so far. And so small enough that if we just sampled, we'd have missed it. But like I said, everyone is a sign of a bug. We also noticed, interestingly, they all happened at around the same time, at 6 o'clock in the morning. So we figured something must have happened around that time to trigger these kinds of events. So from the metrics, we go to the logs to get the full details of the failures, or not necessarily the full details, but more details of this failures. And we saw 24 messages that looked not too different from this one. So we saw that the control value had produced a pair of books that needed to be updated. Our refactored code was throwing the Ruby equivalent of a null pointer exception, which was also very interesting. So between looking at these log entries, looking at our time series database and our existing fun flow logic, it quickly became clear to us where the issue was. And one of the interesting things with certain direct debit schemes is that we sometimes get advanced notifications that something is going to happen in advance of it happening. So we might get messages saying that, okay, this payment is going to land in your bank account tomorrow. We might get a message saying that, this payment has been charged back and it'll be taken out of your account in however many days' time. Now, those kinds of advance notice messages, we don't necessarily want to book them straight away, but we want to hold them, in our case, in an outbox until the right time comes for us to publish them. And what happened was the whole point of this refactoring was to add additional attributes to these normalized messages, but we had messages in this outbox that didn't have these new attributes. And the new logic in the booking process was expecting them, didn't find them, and to use the technical term, it would have gone. And if we had just put this kind of thing straight into production, then we would have seen this very unfortunate ping pong between our booking process and our message bus, where it would have kept trying to the message bus would have kept trying to deliver the message to the booking process. The booking process would have sent it right back saying, I can't process this. And it would likely have overwhelmed our alerting system, and we would have gotten a rather unfortunate wake-up call at 6 o'clock in the morning and pressure to deal with it. But that didn't happen. And that didn't happen because we decided to test this in production first. Our existing code was able to handle this message in the same way that it always had. We were made aware of, in a passive way, of the fact that there was this mismatch occurring, and we were able to investigate it at a more sensible hour of the morning after we've had at least some caffeine in our systems. Now, in our case, we decided no code change actually needed, just need a few days to let these messages flow through the outbox and get all the way flushed through. I was able to go off, enjoy a lovely couple of weeks holiday. Actually got to watch my sister getting married to the love of her life, and perfect day, sun was shining, event went off without a hitch, and I didn't need to think about this refactoring for one moment, which was really nice. Get back to the UK, log back in my first day back, and we saw that there were no further mismatches after all of the messages had flushed through the outbox. All the other mismatches were of a similar cause. And so mid-afternoon after I got back, we had those extra 2 nines of confidence that we needed to be able to put this live into production. And we achieved the ultimate result for a refactoring. We put it live and nobody noticed a thing. And the reason that's a good thing is because, well, the only way someone would notice is if something went wrong. So the fact that nothing went wrong, nobody noticed, that was a win. And we've since been able to take advantage of that refactoring to continue building out our payments network. So that is my story about how testing in production saved us from a significant, potentially significant incident at GC. And I want to leave you with this image. Now, this one was actually from Charity Majors, who is the CTO of the observability company Honeycomb, and I'm nicking this because this puts it far better than I possibly could, and it represents how the meaning of testing in production has changed over the course of the past decade or so. Whereas it used to be about not just being lazy and not testing anywhere else, it's now become an acceptance that it really is the only place where you can test those edge cases that you overlook and that you can't think of. And by testing in production with the appropriate safety barriers in place, as I have shown you this evening, it should reduce the risk of having a change-related issue affecting your production environment and causing you to get woken up at unfortunate hours of the morning, or any other time for that matter. And so with that, I want to thank the LJC for hosting, and thank you all for coming. And I'd now like to open the floor for questions.
Fantastic. Thank you, Joe. That was brilliant. I love hearing all these different talks, because for me, I learn something every time I listen to any one of you share things. So it's amazing. Thank you. We have had one question so far. Feel free to keep putting them in the chat, everybody. So how did you avoid testing in production causing issues to live business hours?
Thanks for that, Robert. So like I mentioned, we had so first of all, we covered the made sure that all of the scenarios that we could think of were covered in our automated test suite. So that gave us a high degree of confidence there. And as for during business hours, so nothing specifically for business hours. You know, we made sure that it wouldn't cause issues at any time, whether it was business hours or middle of the night. And it came back to thinking, you know, how could things go wrong? So we could see a mismatch of results, in which case you know, we made sure that we used the value that our old code had always been producing, and made sure that that was being used properly. And we also wanted to just add some timeouts on the other end, so that if we found that our refactored code was taking a disproportionate amount of time, then there would be a timeout in place behind the scenes to make sure that if it does so, then it'll just abort. One thing about Scientist4j as well, Scientist4j, you can configure it so that your candidate code runs in a background thread. So that will reduce the potential impact of latency in your candidate code, and it'll run your candidate logic and do that comparison in the background without too much of a hit on performance of your live on your live code.
Excellent. I'm hoping that answers your question, Robert. Are there any other questions for Joe? Feel free to unmute and ask, or just put it in the chat. Either's good. I'm going to take that as a no. You were obviously exceptionally comprehensive, which is great. Oh, no, there we go. What would you have done if the testing had revealed more errors?
Great question, Giovanni. So if it had revealed more errors, then what we would have done was, you know, we'd obviously have to go and investigate what caused the errors. We'd use our, you know, we built up pretty good observability that we can usually, in the event of an error or in the event of a mismatch, we can go in and understand why that was, and we'd investigate it in pretty much the same way as any other bug. So we'd have gone in, found the cause, go in and fix it, and we would have extended the period of our validation phase until it had gone on long enough without further errors that we were confident enough to put it live.
Fantastic. I have a question, Joe, and you may well. Oh, someone else has a question, so I'll let Chris get in first. So when you deployed the Scientist4j part, does your deployment mechanism have further protection? For example, blue-green deployment.
Yeah. So as far as further protection, so we do have a full continuous deployment pipeline in place. So this deployment would have run in our staging environment, including the Scientist4j part, and it would have it would have been brought up and run in our staging environment first, and then in our sandbox environment as well. We have a sandbox environment that's mainly used for merchants to test their own integrations with us. So we take advantage of that environment, and as with any continuous deployment environment, as soon as we detect an issue at any point, we halt. So that would prevent the scientist for J from actually getting out the door if it were to cause any issues. And as well, the scientist for J also running as part of our automated test suite, so it would have covered all of those same scenarios that we would see in production as well. Those automated tests ran with scientist for J switched on to reduce the risk of further issues. And we also use Kubernetes behind the scenes, so the normal rolling deployment process that Kubernetes provides gives us additional protection out of the box. Were there any other kinds of protections you had in mind, Chris?
I'm just waiting to see if he replies in the chat. Sometimes people can't unmute on our meetings, so no, just curious what else was involved. There we go. So there's also a question here about making tests in development environment used as another option. Matt.
So with that one, so like I said earlier, running tests in your development environment, so that'll cover that'll cover the known unknowns. It'll cover all of the scenarios that you can think of. And it's absolutely important to run these tests in a pre-production environment of some kind, whether you want to call it development or staging, QA, UAT, whatever you want to call it. It's important that it runs in one of those in advance in order to give you the confidence that you need that it's not going to cause a disaster when you actually go and test it in production. So the testing in production, that covers the stuff that we'd overlooked, the stuff that we didn't think of. Because if we had thought of it, we would have tested it before, if that answers your question.
Excellent. We do have another question as well. So Giovanni says, are the tests still running now that the deployment has finished? And how long do you keep running the tests and have somebody check the results?
So there's two deployments here, which I'm gonna cover. The first deployment that we did before I went on my holiday, where we set up the tests. So those tests ran constantly for 2 weeks, and it ran those experiments, as they're known in Scientist for J. It ran those experiments constantly on every message that came in over the course of those couple of weeks where we ran it. I don't know how often they were checked while I was away, but I took a look at them after I got back, saw that there was enough confidence, and then after I got back and we did that second deployment, that's when we tore down the testing infrastructure and we set the refactored code live, and we deleted the now dead code. But we only did that after we'd seen enough of a breadth of scenarios to get enough confidence where it was safe to do so.
Wonderful. Does anybody else have any questions? Oh, there we go. Another one from Robert. Was the test mentioned in this talk only on a new feature, but with minimum impact to other parts?
So in this case, it wasn't a new feature we were testing. But rather we were testing a refactoring of existing logic, and our ultimate goal was to have absolutely no observable difference in the output, and this refactoring we saw as a prerequisite to the new features that we have been working on since. So, but it was only after this refactoring went live and after we were comfortable with it that we could start implementing enough of these start implementing these new features in a way that in the usual way, basically. So to sort of answer the question, the minimum impact was focused just on the refactoring, because we wanted to make sure that was clean and good and healthy before starting to release any new features or any new functionality.
Okay. I'm going to ask one more time. Do we have any other questions for Joe before I let you all go?
Abby, whilst people are typing, I think you mentioned you had a question.
I did. Yeah, so my question, forgive my ignorance because I am not a tech person, but I'd just be interested to know, is there any one error that you find more challenging than others when it occurs?
Yeah, that's a good question, and it's a difficult one to answer. I mean, I think it's usually the ones we haven't seen before. So there are a bunch of issues that we can generally expect to materialize. We have issues connecting with other systems. We could have a message that we receive that's, for want of a better phrase, garbage. So those ones, are those ones are interesting. The ones that get difficult is sort of the unexpected. So like things like, why are we having a latency spike, for example? So that's not an error per se, but it's still a problem in the system somewhere. So those ones are harder to get to the bottom of. And one of the things that we're trying to improve at GC is improving our observability on things that we think are running as normal, so that if something is happening that's a bit bizarre, then it allows us to more quickly analyze the results.
Cool. You've just been asked if have you read The Phoenix Project by Gene Kim?
I have not, but I will certainly be looking that one up. Thanks for the book recommendation.
Yeah, that's great. I think that sounds like it could be quite interesting, based on what Giovanni said it's about. He says it describes a case of a deployment done in production without tests. So I was like, that would be interesting to hear about, I'm sure.
Yeah, that'll be interesting, because I know, like, thinking 5 years ago, if someone were giving this talk to me, I would have thought they were potentially crazy. So I'd be very interested to see what Gene has to say about this.
Fabulous. Well, since other than that last question about with the book recommendation was the last question I've seen come in while you've been speaking, Joe, I'm going to assume that everybody's had the questions answered that they've thought of already, which is always a good thing. As I said at the start, if you do want the recording of this, please do go to the London Java Community YouTube channel, and it should be there by the end of the week, or message me on LinkedIn. That's my profile there, and I will get you the video when it's ready. So all that is left for me to say now is thank you so much, Joe, for coming and sharing your knowledge with us and yeah, telling us what you know and what you've found out and experienced. It's always great to hear from people. And thank you everybody for joining us this evening. I hope you have a great rest of your evening, and we look forward to seeing you at our next LJC event. And thanks for coming. Have a great night. Thank you.
Thank you very much, everyone.
Thanks.
Bye.
Bye.